Hello, in this video we're going to talk about proteins. Let's not waste any of your time. Let's get right to it. Now when we're talking proteins, hey, one of the things that we have to remember is that they are super important as far as getting work done. If there's a job to be done, it's the proteins that are doing it. I talked about this, or we talked about this back in macromolecules. They do it all, from the DNA replication to just day-to-day processes within the cells. Everything. They're the worker bees. I mean, if it's a job to be done, a protein is doing it, and that's what creates the variety of their functions. You can see the list there beside me, but there's a lot more that they do. We could certainly add to this list, but these are the ones that pertain to what we're going to be talking about. So one, transporters. Okay, we mentioned during the plasma membrane general information that proteins are pathways for items to get into and out of the cell, whether it's a diffusion, whether it's facilitated diffusion with recognition, whether it's active transport with energy being involved, all kinds of things. Okay, the enzymes are proteins. Enzymes are super important because they speed up chemical reactions. Okay, an example of that would be digesting your food. Okay, if left alone to do it on its own pace, the digestive process wouldn't happen quick enough in order for us to get the resources that we needed from our food. Enzymes come along, speed that process up. Okay, super important. And of course, we've mentioned the cell surface receptors that are on some proteins, identifying what it is in order to make sure that it's okay for it to come in. The cell surface identity markers, those glycoproteins that are part of the immune system process, alerting the immune system, hey, we've got something over here that needs to be dealt with. Cell-to-cell adhesion proteins, we mentioned some of these when we talked about the extracellular matrix in our last series. And there was some mention as the cytoskeleton during the organelle talk about that stuff as well. So super important. All right, now when it comes to proteins, what we want to think about is okay, got off my slides there. All right, sorry for the delay there, but I was confused about what slide I needed to be on. When it comes to proteins, there are two types. We're going to talk about one here, and then we'll talk about the peripheral ones as well. But membrane proteins, the super important ones that we haven't mentioned yet, are the ones that span along the membrane. You can see that the membrane there, that's the yellow box that's supposed to represent the membrane. And proteins can span those. Those are the gateways. The peripheral proteins, those are the surface proteins that are part of the cell surface identity markers, that kind of stuff. But these are the ones that go through. They're the gateways, and you can see that if you just think about the protein itself, most of it would be along with the fatty acid tails in there, the nonpolar region of it. The polar region, just like the phospholipids, would be on the edges, and you can have a variety of protein. You can have a single helix, like 1, Okay, you can have multiple single helixes or alpha helixes like number 2 there, or you can have a lattice helix type or multiple helixes as in number 3. Proteins are super complex. We talked about that in the macromolecules, to where whatever's in that R group, you can create various functions, but you can also, when we talked about the levels of structure, you can have multiple proteins bonded together or attached together in that quaternary type system. And again, the peripheral proteins, they would just be sitting on top of the membrane. They're going to be, again, part of that cell surface identity markers. Again, with the glycoproteins announcing that we've got foreign material. Well, that's our video on proteins. The next time we get together, we're going to be talking about passive transport. So we'll see you there. See you then.